Here's a tip that you can use in geometry nodes when working. So let's say you have this plane which for demonstration sake, let me open geometry node. So for demonstration sake, we need to move this in y-axis. Now it can easily be done by just keyframing the y location actually, right? But for this demonstration, we'll assume that we want to use geometry nodes to do that. So I'll click on new. Let's move this for इसको let's name this move in y-axis. Okay, we can then use a set position or maybe a transform node, transform geometry and we can then move in y-axis. Now what I want is at frame 1 should stay at 0, so I'll keyframe this, insert keyframes, and then at frame 70 I want this to move by, let's say, 1 meter, and because I'm working in inches, let me change that. So metric, okay, so I want it to move by 2 meters. Insert keyframes. Did I delete the keyframe? Okay, insert keyframes. So now you see from 0 and it starts moving, goes there and done. The interpolation is wrong, so we can also open our graph editor. You can change the interpolation from here in our timeline itself, but I feel it easier to do it from graph editor. So the keyframes or even the graph is not visible. That is because our node is not selected. So we need to select that node, particular node, so that the graph is then visible to us. I'll also normalize the graph. Select this point, press T and then select linear. By doing this, you see it's linearly transforming through the keyframes. Also this should be at 70. So this is how we usually do it, right? Swap areas, our usual approach of doing this. So this also allows you to easily offset the object from its location. For example, I want this to move there, the animation still persists. It's not like you now need to reapply the offset the entire animation from a particular distance. But yes, so that is one benefit of using geometry nodes. But using each node, and let's say there are like 2 to 4 nodes doing different things, it becomes very difficult for us to keep track of things and how they are going through. And if you want to do any change, then by selecting a node and then going to that particular frame and then changing the values, applying the keyframe again, takes a lot of time, especially when you're dealing with like too many nodes and too many things to worry about. So while making a motion graphic, what I decided was, I thought, what if I make this like customizable and easy to read. And so what I did was I used a scene time node. Now scene time node has two things: frames, seconds and frames. So seconds is independent of frames. So if you want to change, like if you in future are thinking of changing the frame rate of your entire project and you want the animation speed to be consistent, then you can use seconds, else you can use frame. We'll see how we can switch this during our like building itself. So let's try frame right now. I'll take this frame, so it will provide me with a number, and that number will be driven from our timeline, right? That's what frame scene time node does. So what we can do is we can take this, which right now, let's say we are at frame number 1. So this output is right now 1, and we want our animation to end at 70. So what we actually want to do is that as soon as we reach 70, we don't want our animation to continue further. So we want a range of 1 to 70, right, from this scene time node. So what I'll do is I'll take this node, a range of 1 to 70, and I'll use a map range. And I'll convert that range from 0 to 2, because then my 1 becomes 0 and 70 becomes 2. So basically what I'm saying is, take the frame range and convert it in 0 to 2, then use it as my y-axis translation values. So to do this is very easy. Just use a map range, connect the frame to value. Now minimum is our frame where the animation should start, maximum is the frame where animation should end. So the next two values are the values which we want to go in this socket at frame start and frame end. So looking at this, at frame number 1 we have a value of 0, so we want 0, and at frame number 70 we have a value of 2, so we want 2. Take this, remove the keyframes, then we cannot just plug this directly, so we'll use a combine. Just simply type y, combine xyz, take the result, connect into y socket, x and y can be 0, and then connect this. So now you see we get the same exact result. From 1 the animation starts, and at 70 it ends, because we are using clamping. If you don't use clamping, the animation will continue. So we can clamp the values from 1 to 70 and the animation will play. Now we can do something better. We can change interpolation too. How to do that is using float curve. Float curves allow you to edit the curve and change the interpolation itself. Let's do that. But float curves work between 0 and 1. So first of all, what we need to do is take the map range, disconnect this. Let's do that. Our frame will go to value. Again, start frame, end frame, 1 to 70, but this time we're going to max out at 1. This result can be pushed into the value of float curve node. Now what it's doing is it's taking the frame from 1 to 70 and converting it into a range of 0 to 1, which the float curve can process. Now this entire setup can be plugged into our existing node setup, but the minimum and maximum will change to 0 to 1, because of course we're using 0 to 1 range. So it the entire setup is exactly what was before, just that we've added this new map range and float curve node, and we have first ranged it, change the range from 0 to 1, and then change the range from 0 to 1 to 0 to 2. And because this is like simple maths, we could have also just multiplied this value with 2 and like removed this node and use this instead. It would just give the same result, but for now let's keep it at this, right? And now if we play, we get again the same thing, but what we can do now is just bring it in like this, bring it out like that, or maybe a little bit more, and let's set this to clamp, and now if you play, you see I'm getting an easing in and easing out animation. Now if I remove this and move it something like this, I'll get an ease out animation. If I do this, I'll get an ease in animation. So this is a very simple way of setting up our entire animations. Now how can we use this even more? Let's say what I want to do is, let's remove this. I'll just rename this to demonstration, remove this plane and add a monkey there. I want this monkey to rotate and scale up from 0, so it will appear rotating. So I'll use this same setup, geometry nodes, and same setup, demonstration. What we'll do is we'll remove this transform, or maybe make it 0. Okay, So this will go back. We need to use this rotation now and rotate in, I think, yes, Z. So let's see how we can rotate that in Z. So my frame range will be the same, 1 to 70. So this is fine. This is fine for now. Just that from 1 to 70 we're going with float curve, and I want it to ease out. So I'll just do this. Now it's on ease out mode. And combine again. This time combine with Z. Plug it into rotation. Now the value, what should be the value? So usually what I do is I just use math node and set it to 2 radians. Now I can use a degree value for angle, and that would be converted into radians automatically and be used for rotations. So let's see how this looks as of now. So nothing happens because the angle is very small. It's like 0.5 degree. Let's change this to 360 degrees. You see single rotation. 540 maybe. So I'm not very sure how this will look, but yeah, this looks better to me for now. So our this is done. Like, we have our rotation is done. We need to scale this now. I'll just copy this again, and I want this to be controlled by the same float curve. So this is for my rotation, and now I'll use one more for scale, and scale should be from 0 to maximum 1. So I guess we don't really need this because we already have the range from 0 to 1. So I can remove this and plug this directly into our scale. Just let me just organize things a little. That's better, so that it's easier to read and understand. Okay, so now we can play our animation, and you see how it's now also scaling up, and with that scale we also have the rotation. But we can do something better. Like, we can always change this to 40 and have faster animation. Animation will end at 40 now. So every time what I need to do is I need to change minimum and maximum, like frames. The frame where the animation will start and frame where the animation will end. So I can take this group input node, or you know what, let's just do one thing. Duplicate this group info node, bring it here, and we can connect these two so that they're visible out. Then we can press the N panel and rename these from minimum to start frame, and we want this to be an integer. Similarly, end frame, also an integer. There. Now I can specify the start frame and end frame for this monkey. Let's say start frame is 10 and end frame is 60. Now the animation should start at 10 and end at 60. Doing this, we can also duplicate this monkey just like this and change the start and end frame for each. Like, let's say the start frame now is for this one is 40, and the end frame is of course plus 30, that is 90, and for this it is 30, 25, 20, and end frame is then 70. So now we get this exact same animation for all three, but again we can change this interpolation, and it will change the interpolation for every single monkey, which is a nice thing. So we have some control per object basis, and we have some control to the entire object. That is why geometry nodes is very powerful. Now one more thing we can do is every time I need to change start and end frame for every single object, I can make this even better. How? So first could be start frame, but the second input could be my duration. So basically how long the animation will last. And now I can take start frame, but now how will I get that end frame? What is my end frame? That end frame would be my start frame and my duration when added. So basically if I'm starting at, let's say, frame 10, and the animation should last for 50 frames, then adding these will give me that I need to end the animation at 60. So simply add them, and this is your end frame. You can even like give it a tag. So go to node, label, and end frame. Just plug this into from, and now I can start frame. Let's say this is 50, yeah, 30, and duration is 50. For this it is 20 and duration is again 50. For this one it is again 50. So now we have exact same animation, exact same duration, just starting with offset. Also what I can do is I can select this, increase the start frame whatever we want, and then the animation will of course offset itself to that start frame and respective end frame. I can also increase the duration for particular single objects. Now can I use this in a much complex way? The answer is yes. Like let's say I have a plane. I'll just scale this up quite a lot and subdivide it like this. Let's remove these monkeys, right? I'll create a new geometry nodes animation. It's a good practice to do this if I'm learning. And what I'll do is I'll distribute point on faces, distribute. Then I can take this point and instance on points. What I'm going to instance is cone, maybe cone would be good. Mesh cone, just like this. Let's reduce the density a little, and what I'll do is I'll reduce the vertices to just 3 to keep it very simple, while also bottom radius I'll do this something like this, so they look more like grass. And now we know that we have this instance. For this instance thing we have this selection part, right? So what I can do is just reduce these. So for this selection part I can bring in position just like this, separate it in XYZ. Now if we like look at this X value, why is this not acha? Okay, so you see how we get a gradient in X direction. What we can do is take this X value, check if it is greater than or less than, and let's say greater than less than 0, result into selection, and if it is greater than 0, then which is this side, we get cones. If it is not greater than 0, then we don't get cones, which is a very simple way of doing things. We can also just add some values or subtract some values to increase or decrease the area in which the cones appear. Now this value which can be animated, let's remove this. So this value can be animated to show as if this grass is growing from one direction to other. So to do that, again I can bring in my scene time. Let's take again the frames and map range from 0 to, so let's see, I'll do the same. I'll take this group input and have 2 inputs, so for start and for, where is it? Yes, so start and duration, just like this, and it will map to 0 to 1 for now, but let's see what we actually require. So I want this to be from like here 0, nothing appearing, to all of it. So kind of from minus 13.5 to 13.5. So minus 13.5 to 13.5, and just plug this right there. Now let's set up a start frame, which should be I didn't made it integer. So this should be integer and this should be integer. So let's make our start frame to be 10 and our duration to be 100 or maybe 50. Not 150, but 50. Okay, I need to go a little more, like 0.75 maybe. Yeah, nice. 0.75 is fine. And when we do this, we get our animation. Again, if you want a slower animation, just increase the duration and you get a slower animation. You can even like make these scale instance, or maybe just take this add thing, clamp it between 0 and 1. Yeah, let's just do this. I'll plug this into scale and you see what I get, this thing. So kind of like this, but I don't want the scale to be, this is because the scale is going, the values are going both negative and positive, so I can clamp this in between 0 and 1 and the result will go into our scale. Now if I play, you see they're actually growing. Let's clamp that at 2 so that they're much better visible there. See how they're growing one after other. So that's a very cool way of simulating things. I guess simulating, not sure. But we don't want to set up these every time we are making something, you know? So there's a much better way to do this, and that is just create a node group. So to minimum to maximum 0 to 1, and what we can do is just take this entire thing, like only this thing, not that. Take this thing and press Ctrl G to make it its own node group. Then my result will go out. This will be factor, maybe factor, because the value is from 0 to 1. This will be a factor, and we are using something like this. So we are using from minimum, from maximum, which should be again integers, integer, and it should be not from maximum but start frame and duration. It should also be integer. There, start frame, the default should be 1 and the minimum should be 0. For duration, the default should be something like 30. By default 0 is not fine with me, and the minimum should be 0. Great. With this, we have set up a very simple node group. We can also expose these 2 max and 2 min and set it as start value and end value. So by doing this, we have a node group which we can name scene time animation. So we have a start value and an end value, which can be controlled by plugging them into group input or just leave it like that, which outputs a factor which is between 0 and 1, and we can control this by selecting these two values on even using a float curve in front of it. So, and by saving this as an asset, mark as asset, we can use this anywhere we want. Scene time animation node. So that was a very I guess brief video about how we can use scene time node in conjunction with map range node to create something better, a better tool to animate. And I've been using this almost everywhere in my project. So yeah, I guess that's it for today. We'll meet again. Till then, subscribe, like if you like the video. If you didn't, it's fine. I'll make sure to post something else which you might find useful. So subscription would be much appreciated. Thank you very much.